Hey guys. So, I want to go through and give you guys, kind of show you what we're doing here with this worksheet. Uh, so, this is just going to be a kind of me doing one of these problems. So, I'm going to do number one for you guys. You're going to take this sheet and basically just go through, take these abundances, these percentages of these elements, and they give you the molar mass. From this, you need to tell me the empirical formula and the molecular formula. So this is just pretty straightforward. There's no story involved in this or anything like that. So it's pretty much just go. All right. So remember, when you're dealing with this, you now have these abundances. What's the first step? Well, the first thing is you got to get to grams. You got to get to grams. And how are you going to do that? Well, what you can do with percentages like this is just assume 100 grams. If you assume 100 grams, then that means that these percentages, what's 26.4% of 100 grams? Well, it's grams, right? So you can turn all these things to grams. Nice. Okay. All right. Cool. At this point, what do you do now? Well, you have grams, but we can't really compare grams to grams, just the same reason we can't compare watermelon weights and orange weights. We need to get to numbers, and for that, we need to get to moles. So we're going to go from grams to moles. What we can do here is divide each of these by their molecular weights. So carbon's molecular weight is 12. Hydrogen's molecular weight is 3, and oxygen's is 16. All right, so 26.4 divided by 12. I'm going to grab myself a calculator and do this. 26.4 divided by 12 is 2.2. So 2.2 moles. This is going to be 3.3 moles. I don't even need a calculator for 3.3 divided by 1. The other one is 70.3 divided by 16 is 4.39 moles. All right, so now we have numbers, but none of these really make sense. They're not nice round numbers like a formula. It's not C1H2O4 or whatever. So what do we do now? What we do is we take the smallest one of these, and we're going to say that's our 1. So that means 2.2. We're going to divide each of these. To make 2.2 1, we're going to divide it by 2.2. That means we have to do that with all of these. Okay? So 2.2 divided by 2.2 is 1. 3.3 divided by 2.2, 3.3 divided by 2.2 is 1.5. Curious. This is not like our example in the lecture yesterday. And then for oxygen, it is going to be 9 divided by 2.2. And this is pretty close to 2, right? It's pretty close to 2. So we're going to just call it 2. So what do we do here? We can't have hydrogen be 1.5. We can't have half a hydrogen. So what we do in this case, anytime you have a 0.5, what you do is just double everything. Okay? And that's your empirical formula. That's the ratio. So if we double everything, it's going to be C2, H3, 1.5 times 2 is 3, and O4. Now, remember, this is just the ratio. This is not the actual molecular formula. To get that, you have to have the molar mass mixed in here. So to do that, what we're going to do... My cat's messing around back there. Hey. No, sir. Get out of my computer. Okay. To get that, what we're going to have to do is figure out the molecular weight of this molecule. Okay, that's pretty easy. 12 plus 12 for the carbons, and then 3 for the 3 hydrogens, and then 16 plus 16 plus 16 plus 16 is 91. Hey, this is 91. This molecular weight is 91. The thing that we're after is 91. So the molecular formula is the same thing. Huh. And there we go. Done. Check. All right. The rest of these, looking through here. Yeah. The rest of these, you might have to go through and do some doublings if these molar mass of the molecule doesn't match what the empirical formula is. Okay. Excellent. So that's that. Hopefully you guys got it. Have a good one. I will see you guys on Tuesday for the quiz. Don't forget to study. Have a good one.